All right, let's see if I can. Yeah, okay, looks good. Sounds working. All right, good morning. Welcome to day 2 of Advent of Code. I got stuck on part 1 and actually couldn't finish. In fact, I'll just show you the 2023 Rust. I did end up fixing it, and I learned a bit in the process, so let's take a look at this. I don't want it to ask me about that. All right. So in day 1, let's see. Let's go to this thing. Okay, let's see. Is that big enough font to see on stream? Could probably be a little bit bigger. All right, let's do that. Okay, so in day 1, the issue that I ran into was that let's actually go to part 2. When we did the replacement, then we'd run into problems where we would do this, and this one would parse as 1 before it would parse as 8, and would replace the whole word, therefore ruining the ability to parse the 8. And then I tried parsing it sort of front to back and then back to front, and that was messy. And so then I started doing it character by character, which worked. And I actually saw a tip from somebody on Reddit, and they did their replacement in a way that would feed the one strategy into the other, which I thought was pretty clever. It would sort of break in some situations because these words only ever overlap by one character. So by replacing 1 with, instead of replacing it with 1, we replace it with O1E, thereby removing the word 1, inserting an actual number 1, but still allowing anything front or back to continue to parse. I thought that was kind of an interesting solution. It ended up cleaning up quite a bit of code. So in this case, it did work. It's probably better to iterate character by character, but it doesn't matter too much. So if we look at the Safari window, which I don't know where it went. It is right here. All right. So if we look at day 1, we've got 2 stars, and let's open up day 2. All right, Cube Conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. He explains you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. To get the information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and put them back in the bag. He'll do this a few times per game. You play several games and record the information from each game, your puzzle input. Each game is listed with its ID number, like 11 in the game 11, followed by a semicolon separated list of subsets of cubes that were revealed from the bag, like 3 red, 5 green, 4 blue. For example, the record of a few games might look like this. Okay, game 1, 3 blue, 4 red, 1 red, 2 green, 6 blue, 2 green. Okay, in game 1, 3 sets of cubes are revealed from the bag and then put back again. The first set is 3 blue cubes and 4 red cubes. The second is only 1 red cube, 2 green, 6 blue. Third set is only 2 green cubes. The elf would like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. In the example above, games 1, 2, and 5 would have been possible. However, the elf showed you 20 red cubes at once. Okay. So we're looking for maximum of these 3 numbers. All right, so let's go ahead and get started. I'm going to close this one. By the way, I also was doing some practice on last year's Advent of Code. Some practice. And I was doing it in Rust so I could practice using nom, because I think that's going to be useful. Not quite sure if this music is loud, too loud or whatever. So let me know. Okay, so let's go into 2023. So I'm going to do cargo new, day 2. We're going to do that. I don't think I ever wanted to ask me about that again. Actually, I'm in the wrong spot. I need to go day 2. Okay. We're going to rename this to lib.rs. We're going to make a new folder called bin that has a new file called part1.rs. Then we'll move this into there. I'm actually going to swap these, I think, so I can see it better. All right, so this is hello part 1. Lib has nothing in it right now. That's fine. Let's open up our terminal, and I wonder if I can do terminal on the bottom. I'm not sure if this is going to work a little bit better. Maybe it will, maybe it won't. I don't actually want it to be there. I want it to be here. Okay, and then I'm going to do that so that we don't have a bunch of extra junk in there. Okay, so we're here, and I can do cargo run -- bin part 1. And we should see hello part 1. And we do. All right, so I can also do cargo watch, and I figured out how to get it to run whatever command we want. So we do -x, and so here I can say run -- bin part 1. And now, as I make changes, it will run it. Now, if we wanted to do the tests, which I think maybe is what we want to do, I'll start by just building it so that we can see build errors. But when we run tests, we'll have it run automatically as well. All right, so this is our sample input. So I'm going to go over to here, let's create a new file called part1.rs. This one is going to have a function called process, which will take, I'm going to make that a little bit bigger again, because it seems like it might be a little small. All right, so it'll take a string slice as input, and it's going to return a string. So that's going to be kind of our general shape. So for now, we'll say to do. Then we will have our test. So that's CFD test, mod test. We're going to use super star, and then we're going to have a test function, test sample input. I did see something yesterday where somebody used RS test, which I don't know if is included. I'll have to do some research on it. But they were able to pass in, like, expect that, you know, A equals 1, and then just basically do that for each one of the tests, which was cool because it turned one test into many tests with lots of different samples, which I thought was really interesting and is useful for this type of thing. All right, so we're going to say let input equals this. And this actually may be a good use of nom now that I'm thinking about it. And then we're going to call we're going to assert equal that the processing of this input is equal to, and I think it's 8. If you add up the IDs of the games that would have been possible, you get 8. All right. I think I want to make this a little smaller now. Okay, so we'll have to begin by sort of starting to parse out each line. So I'm going to say line, and what do we want to get out of each line? We want to get we could build a struct that contains the game ID and the number of blues and reds and stuff. So this is going to be a game that has an ID, which will be a U32 or something. It will have a count blue, which will be a U32. This will be count red and count, let's just name blue, red, and green. Okay, so we have a game struct. This is the type of thing that might end up needing to go into, because we would reuse it for part 2, but I can just copy and paste it, it's fine. All right, I'll keep the process function at up top. It also has to be public so we can run it. And as we're going, the terminal output is continuing to run our code, which is pretty cool. Trying to see what my keyboard shortcut needs to be for that. I can do Control tilde to open up the terminal, but then it doesn't close it. Let's see. So that's, and then view problems output terminal option. Okay. Option backtick. No, that does not work. Option backtick. Oh, you know, that may be something that that Mac OS is doing differently. Yeah, I don't know what's happening here. Control Yeah, that does not work. Okay. I'm not quite sure. We're going to have to move on, and I'll hit Command Y twice to open that, or close it, and then that to open it. Okay. All right, so when we parse the line, we expect to get, say, a vec of game instances, right? No, that will just give us one game instance. And I'm just going to assume that all of this will be successful, so we'll unwrap the results here. Okay, so then we can say let's see, why am I not getting any kind of Rust Analyzer? Doesn't seem to be working. Is that because I need to add? Yeah, that's why. I need to add that there's a module called part 1. Okay. And now if I do line, okay, there we go. Okay, so line, we know that every line starts with game space. So we can say replace game space with nothing. Then we can take the next, so that's going to be line equals. And if we go look at our output here, so let's say ID 0, red 0, blue 0, green 0. No semicolon. Yeah, I think that I need this to be taller, which means I want to put it back over on the side. And we'll just make it full screen, and I'll just adjust when we need to look at the input. Okay, so this says expected game found. Okay, so the reason why that's happening is because I forgot a semicolon here. And game expected a string. Or sorry, this expected. So replace returns a string. Which I suppose makes sense because we're working with a borrowed reference, right? A string slice. So we're not able to mutate this. I wonder if I can just do this. I don't really need to mutate the underlying string. So I think I'm just going to create it as because in this case, it's expecting, let's see, if I do a borrowed reference there. Yeah, that doesn't work. Okay, so I think I just want to say to string. And cannot assign twice to immutable variable. Okay, so now we have our line as a string, immutable string. We can replace game with empty. Sorry, that needs to be game colon space. No, the next character. We can do line.characters or chars.next dot unwrap, and this one is going to be a character that is a number, and we want to parse that as a U32. So if we do ID as U32, you can cast a chart. Well, I don't want to cast it, I want to parse it. Parse not found in char. Okay. We did this in day one, didn't we? Just want to quickly peek into day one and see what we did for. We did c.toString.parse : U8. Okay. All right, that'll work. Unwrap.toString.parse. And parsing can also fail, so we need to unwrap that as well. Okay. So now we have the ID, and now we can replace this and just use the shorthand syntax because those lines match up. The next part of our input was this guy. So we'll have a count and then a word and then a comma. So we can split. Oh, okay. Each game has multiple runs. Okay. I think we need to change this to struct game run. Move those here. And then this one will have runs is a vec of game run. Do I care about that, or I just want the maximum? I feel like I should just parse out all the input and get the data first, and then I can use these rather than do it in the middle of the parsing. Okay, so we've got a game ID now, but now we need to split the input. Yeah, I kind of feel like I want to do nom for this because nom was built for this sort of thing. I was thinking maybe I would do it the brute force way and then replace it, but I'm gonna have to go through and do string splitting, right? So if we split on the colon, then I get left half is the game stuff, right half is the runs, which is helpful, and then each one of those is split on the semicolon between each run. Yeah, that's easier, and then if we have time, I will do the nom refactoring so that I can practice that. Okay, so instead of doing it like this, we're going to parse line is going to return a game, but I also want to have a function called parse game. So this is just, it's not going to take the whole line. It's just going to take some input string, slice, and return a game. And so what we're going to do here is what we did here. We're going to I'm pretty sure we're going to end up with like 1,000 games. So we need this to be smart enough to just pull out the entire number. So this actually won't work, right? Because that only works for a single character. So we need everything from here. Yeah, so I think we're going to do line.replace game, and whatever's left is going to be parsed as a U32. Yeah, I think I'll do that. Okay, we're going to start off with input.toString dot replace this. So game space becomes nothing, and we'll be splitting on that, so we don't expect anything else. So the rest of the string can be parsed as U32. So we're going to do ID equals U32. Then we will call parse on the results and unwrap it. We can also expect it, so should be a number. So we'll actually get a better error message. And now this can return a game with the ID, and then the runs is going to be an empty vec because we need to mutate it later. Or do we want to do that? If we pass in the entire line, then yeah, I think I want to do that. Pass in the entire line here. Yeah, I think I like this better because then I can take the parts of the line and split it on colon. I think there's a split once. Let's look. Let's see. Rust split once. Okay, this. Let's go look at standard string split method. Oh, we do have it. I don't know why I just didn't jump. Okay, so yeah, so now if we do split once, we get the first and the rest. Okay, that's what we want. So we want the game stir and the runs stir to be line.split once on that delimiter. Okay, so here we want to take game stir, and I think we can just split once on the space because we don't care anymore. And then we want the second item from split once. Okay, game runs. It's complaining about all this stuff right now, so let's just say to do. Okay, so split once might not find it, but we know it will, so we'll just say unwrap. Then this one, we'll unwrap this as well, and we'll take the second part of this, and we'll call parse, and unwrap the result of that. Okay, so now runs can be the result of calling parse runs with whatever's left of the runs string. And okay, so function parse runs. So this needs to return a vec of game run. And here we're going to take line.split on semicolon. And is there spaces in our output? Semicolon space. Yeah. Okay, so for each one of those, we can call map. And this will take R as a string, slice, and then we need to figure out if this is... I feel like I should just move this again into another one that is parse run. Yeah, I think I want to do that, and this is going to be input, not... And then that's going to return a game run. And again, I'm just unwrapping everything, assuming that all the input is going to be fine. I like doing it this way just because I'm making much smaller methods that are easier to understand, easier to test. Okay, so here I should be able to call map with parse run directly, which is pretty nice. And then at the very end of that, because I have an iterator now, I need to collect it, and it'll figure out what type because of this. Okay, so now we're on to parse run. Parse run is going to take this content. I actually want to split that game stuff on not just colon, but colon space, so that we eat that. So that we eat that space. Okay. 3 blue, 4 red. So there's no guarantee that we're going to get any of the items. They may not also be in that order. So if I split on comma space, then I'm left with multiple lines where I need to count. I need to figure out with a match statement, I guess. Okay. So we'll split on comma space. For each one of these, so basically I want to reduce these, I think. I'm not quite sure how I want to do this, because if I map this, I have a list of colors, basically. And that doesn't help me because then I don't know what color it is. So I think I just want to do maybe a for each here. And we'll say let mut r equals 0. These probably need to be known as U32. And then we'll do G and B as well. And then here we will say for color in input.split. We are going to we're going to say color stir dot split on space. We want to split once again, unwrap, so we make sure that we get it because this takes the color and the count. And here we can match on the color. And if the color is red, then we're going to mutate r equals count.parse.unwrap. And then the same thing for blue and green. Okay, GB. I think I could just do this here. This is going to be count stir. Let count equals count stir parse.unwrap. Maybe an easier way to do this, but now these become a little bit easier. Count. Okay, and so at the very end of the match, we now have, or sorry, at the end of the at the end of the for loop, we have all of our entries. So now we can return a game run with blue, red, and green. And I think I just want to call these. I don't remember how to select the next occurrence. Add next occurrence. No, that didn't work. So I'd like to just replace this. This is, you know, more learning. I know I can do multiple cursor manually, but there's a way to automatically select this. Let me do a quick search. VS Code automatically select same text. That's really add cursor. Control D? No, but that's the problem with this type of stuff is Control D is a Vim command. So Control D is down, Control U is up. So I would have to change that. All right, I will do it the manual way. Also, these. Oh, I'm doing. Yeah, that's annoying. I'm doing the Xcode multi-cursor editing. All right, so this is going to be red. So I'm option clicking so I can do both. Then I can do it in Vim. I can do it in Vim mode if I do it this way. So if I had my cursor here and here. Right, we already did red, so I'm gonna hit escape J to go down. I'm gonna find the G. I'm gonna append green. And I'm gonna go down to this line, go to the beginning, find the B. Yeah, I feel like I am just easier in Vim. Okay, so we have all those set up, and so now this becomes blue, red, green, like that, and we're returning it. Unexpected closing delimiter on line 51. Okay, so now that we've done sort of all the hard work, we know how to parse a game from a line. That will parse runs. Parse runs will split on the semicolon, parse each run individually, collect them into a vec, and then that gets assigned to the game. So I think that parse line now is just much easier. Let game equals parse game line. And I think that now we just need to look at, let's double check our thing. Which games would have been possible if the bag only contained, okay, so we need to know, so we need to collect all the games and then do our results. So this is going to be parse games instead of parse line. Is that right? Because we actually don't even need this. Or that. Okay. Let's make sure we've got something wrong here. I don't know what happened there. Let me go back. My input got all messed up. Yeah, okay. We don't need parse line. Yeah, that's really weird. I'm not quite sure what happened. So this was our test. Test sample input. And that is a test. Okay. We are calling process. Okay. So now process the input can take the input and parse games out of it. So we're going to say let games equals parse game for each line. So let games equals input dot lines. Map that to parse game, and then collect it into a vec. And we want to filter out the ones that don't match. So in our case, our max red was 12, green 13, and 14 blue. Okay, so max red was 12, max green was 13, max blue was 14. So now we can call filter, because now we have our game, and we want to make sure that the game.red is less than the max R, and game.green is less than the max green, and game.blue is less than the max blue. Max B. Okay, is it less than equal if it only contains, so less than or equal to on each one of these. Okay. Then we collect the, well, we need to get the IDs out of that now. So that is now get the IDs, and then we need to sum the results. We don't need to collect. Okay, so this is let results, and now we can just print out the results. Return the result to a string. So that's going to be format bang this result and return it. Okay, game.blue is unknown field. Oh, yeah, duh. I need to make sure, yeah. We need to filter this. This needs to be the run. So it's going to be game.contains or any. Right, game.runs.any. That needs to be an iterator. Any. And that takes a function which takes the run for that game. And now we can replace, change this to run. Okay. So that's going to return whether or not any of the any of the runs for that game contained. No, we want all. Because if any of them pulled out more reds or blues or whatever than the max color, then that game could not be counted. Okay, so result at this point should be a U32. Let's look at line 50. We need commas here. Line 47, semicolon. Also here, old habits die hard. Then the maxes, which were way up here. So those all need semicolon. Okay, now we have a to-do. No, do we? Match color pattern. Oh yeah, so in our match statement, we, similar to Swift switch statement, we have to handle the else case. So anything else, I think, or no, it's underscore. And here, we need to panic, like bad input. Or maybe we don't care. Maybe we just do nothing. Yeah, okay. Parse run is never used. Is that true? Parse game, parse runs is saying that because it's not used as part of here. So, so if I do that and then part1.rs, this one needs to pull it in as use day 2 part 1 process. And now we need to get our input, and that's going to be include stir. We'll do out of the bin directory and grab input.txt. And then we will print line part 1 is process input. Okay, could not compile. That's a private function. Oh, okay. That needs to be a pub function. And now it can't find the input string. So let's go grab that. We'll go grab our sample input. Okay, save that. And now it panicked. All right, unwrap, parse int, kind, blah, 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 invalid digit. So that was line 47. So what was the count string here? One interesting thing we can do is called debug. And debug will output and return an item, which is really useful. I think last time I was creating temporary variables just to print them out, and just wrapping something in debug is pretty nice. But I think what's happening here is that it's capturing standard out to make the output cleaner. And I think, is that happening with run? I know it happens with tests. Let's take a look at -- no capture. No. Oh, no, it did work. It did work. Was it printing it out up here too? It was. Okay, so that's only in tests. We need the no capture thing if we want to see standard out in tests. Okay, so what we're looking at, count string is green because I flipped them. The color was second. So this needs to be count stir, and this needs to be color. Okay. And we got our results. I can get rid of a debug here. Make sure that that still works. Okay, let's go see if that puzzle input matched, or that answer matched. That was 2165. Not the right answer, it's too high. All right, so this is where I want to run a test and make sure that our tests pass. So we're going to, let's add cargo watch -x test -- no capture. Now we're running our tests. One test failed. Result.unwrap on invalid digit. That was on line 31. Let me print out this just to make sure the multi-line string is working. Print line input. Yeah, that's the problem. We have some white space at the beginning. In order to get this to look right, we need to do this. We could strip white space from each line, but okay, so our tests passed. So our number is too high, which means we're including too many games. So let's take a look at let's take a look at our filter here. So we get all of the games, then we're filtering it, looking at all that game's runs, making sure all of them are less than or equal to the max. Run.red, red, green, green, blue, blue. 12, 13, and 14. 12 red, 13 green, 14 blue. Okay. The bag only contained that, so we just need to make sure that we're less than or equal to each one of those. If you add up the IDs of the games, that would be possible. So that's what we're doing here. We get the ID and the sum. Okay, what's happening? In our parse run function, let me make sure I have this correct. Red, here we go. These are out of order. Blue, green. It's curious that the test still passed when I did that. 2076. Okay, continue to part 2. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you to get ahead of the water source to check it out for yourself. It's just up ahead. As you continue your walk, Elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? Okay, that should be easy. In game 1, the game could have been played with as few as 4 red, 2. So we just need a minimum of each one. The power of a set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. Okay, so let's take part 1. We're going to add a new bin for part 2. We will add I think I just duplicate this and call it part 2. Yep. Okay, that's all good. Part 1 is fine, and then part 2 bin is going to be the same as this. So this one is going to be day 2, part 2, and part 2 process. Okay. So now we're going to be running. Let's do tests for part 2. I'm not quite sure how to exclude the tests that we don't want in here. We need to tell it about part 2 in our lib.rs. Because I would like this output to be a little bit shorter. But that's fine. All right, so we'll close part 1. Now we're just looking at part 2. And part 2, so as we process, we need to capture for each game. So rather than filtering, we need to return, say, a game run with the minimum of each entry. Yeah, so we're no longer going to be filtering. Let's get this a little easier to read. All right, so we're no longer going to be filtering. So we map the game, and now I want to map this to game runs. So each one here is a game. And if I say I want to take, let's say we do game.runs.map. Why is that not working? .iter. Sorry, I've got to do it. .iter.map. But here I want to take the minimum of some function. And I would have to do that 3 times. I think this would be easier with a for loop. So we could do let mut min min r 0. I don't know why all those are I32s. Those should be U32s. U32. I feel like the inlay hints are really helpful, but they make it really hard for you to edit the text because it's hard to see what is actually in your editor and what's being overlaid. I need to figure out how to turn that off. Okay, so this is green and blue. So we've got the minimum. 0 seems like a good minimum, but it's actually not a good minimum because we basically need this to start at the first one. Because otherwise this is going to be the smallest number always. And I don't know what to use for, I don't know, U32 max. It said max value was deprecated. Oh, it's a constant. All right. So if I do U32 max for each one of these, then the first one we get to. All right. So we're gonna iterate over each one of those. So this is gonna be for run in this. If the run.red is less than min r, then we're going to say min r equals run.red. And then we can do the same thing for green. And the same thing for blue. All right, so now I needed to return the, I'm going to return a new game run with red as min r. Blue is, I wish I had renamed those. I'm actually going to do that. Not rename them, reordered them. Red, green, and blue. Maybe it doesn't matter, honestly. I'm not sure. Let's find out. So if I want to create a game run with blue as min b, red, yeah, it does work. Min r and green. Yeah, that's interesting. I kind of like that. But let's move this over here. All right, so now we're returning a game run, and for each one of those, I want to map that now to the power of that game. So this is going to be our game run, and we're going to do game run dot. We could probably do this as an impl on game run. Impl game run. Fn power returns a U32. So this is just going to be red times Sorry, that needs to take a self, so it becomes a instance method. Red times green times blue. What is it complaining about here? Oh, I need to use self dot on each one of these. Okay. So now when I map here, we can just map that to power. And I'm not sure if I can do game run.power like this. Does that work? Expected value. Okay. Yeah, I'm not sure how to reference an instance method like that in the map, but we can do this. gr.power. Okay, so now I've got the iterator there, and now I think I still need to sum them up in the output. Yeah. So we should be getting 2286 for our test. So when we run this same input, we should get 2286. And we're running our test. Left was 2. That's not right. Is it running? I can't tell. Yeah, it's just very fast. Okay. Let's go back up to our process function. So we have our minimum. If the run that we're looking at is less than that number, then we'll assign it. So we keep track of the minimums for each run in that game. Then we map that to the game's power, which multiplies them all together. No, we need max here because we're just trying to figure out what is the maximum number in here, not minimum. So yeah, so these need to start at 0. And then this needs to be greater than. Which fixes our test. Yeah, the wording tripped me up there. All right, let's go over to running day 2. And we get 70950. Let's grab that and put it here. That's the right answer. Okay. Sweet. This one was a little bit easier, more straightforward. I'm still struggling with the VS Code and the Rust a little bit, but things are getting better. I am interested in using Nom for this, but I'll probably do that later. It definitely would have made all of the stuff easier to read. And the benefit of using Nom is you're always operating on a string slice, and what you end up getting is smaller and smaller window of a string slice to work with. Well, I guess I am still doing that here. It's just harder to read. It's harder to tell what we're trying to do here. But anyway, all right. Thanks for watching, and hopefully see you again in the next one.